Hello, thank you very much for your purchase of the RMC glass knife maker. We sometimes refer to this instrument as the GKM. First, I want to show you what you get when you unpack your instrument. You'll find the instrument itself, the instruction manual, a brush, a box of glass for making glass knives, 2 micrometers which we need to attach to the instrument in just a moment using this wrench which also comes with it, a pair of safety glasses which you should wear when you're making glass knives, and a dust cover for the instrument when you're not using it. One more small item I'd like to point out is that inside your instruction manual you'll find a small bag that contains spare scoring wheels and a scoring wheel shaft. Please don't lose these valuable spare parts. You may want to attach them to the inside of your instruction manual so you don't lose them. Now let's go ahead and install the micrometers. Notice that there are 2 of them. One's labeled front and the other's labeled back. Actually, they're identical, but the boxes have numbers written here, which we are going to refer to later when we make our initial adjustments. Let's start with the back micrometer. I'll take it out of its box, out of the bag. Then I'm going to back off on the micrometer knob here so that the cylinder goes back, so that when you insert it into the hole here, we can push it all the way in and the cylinder at this point is not touching the ball. Now we can rotate this cylinder here, the scale, so that we can read the numbers conveniently. Checking again to make sure it's all the way in. And now I'll go ahead and tighten the set screw in the back using the wrench provided. Now we'll go ahead and install the second micrometer. Again, we're making sure that the cylinder here is not touching the ball. We're rotating the scale here so that we can read it, making sure we're all the way in, and then we tighten the set screw in the back. Now let's describe what the glass knife maker is for. Its purpose is to take glass strips, produce glass squares, and then from the glass squares we make diagonal breaks to produce triangular glass knives with a very sharp cutting edge here at one corner. With the RMC glass knife maker, it's very easy to produce glass knives using the balance break method. With this method, we take the 400 millimeter long strips of glass and we break them in half to form 2 200 millimeter long strips, later 4 100 millimeter long strips, 8 50 millimeter long strips, and finally 16 25 millimeter squares. Actually, this last one we can't use because it'll be slightly too long. So we end up with 15 usable glass squares, and each time we produce them by breaking the glass strip in half. So the pressure was equal on both sides as we broke it. Well, now what do we do with these 25 millimeter square pieces of glass? Let me draw one somewhat larger this time. We take it and put it in the instrument and do what we call the diagonal break. In this case, we make a score underneath the glass in such a manner that when we apply pressure on both sides, actually we apply the pressure in the middle and there are pressure points underneath, and this causes a bubble to form, the beginning of a fracture, and then this fracture shoots off to both ends and forms 2 glass knives. These corners right here are the sharp corners of the knife. Now let me describe what the micrometers are for that we just got done installing. Let me put another piece of glass in our instrument, and as you'll see in a moment, we locate the square in 2 notches. And as you'll see, the position of these notches is controlled by the micrometer, which I won't draw here. So by moving the micrometers, we change the position of the diagonal of the square. Now we can't move the scoring mechanism. It travels in a groove, as you'll see. But by changing the position of the corners, we can change where the score will go and where the final break will be, so that it'll come out very close to the corners, but not exactly on the corners. So why does the RMC glass knife maker have these precision micrometers? Other glass knife makers in the past didn't have them. Well, the reason we put them on there is because it's actually very important how we line up the glass. Let me just show one corner in detail. What happens is we've made our score, and the position of the score is determined by how we lined up the square in the instrument using those micrometers. Now what happens during fracture is the fracture widens, and finally it breaks all of a sudden, and it shoots towards the ends. Now it happens that if it doesn't shoot right to the corner or very close to the corner, as it gets towards the end it'll veer a little bit. And as you can see, that results in a knife edge that's not 45 degrees. In fact, at the actual edge, it may be 60 degrees. Even though the score is about 45 degrees with reference to the square and the two sides of the square. The actual edge may have an included angle of 60 degrees, and that's not very sharp. So now let's use our micrometers to position the corner differently. Again, I'm just showing one corner. So now our score is going to be positioned such that when it fractures, the fracture will travel closer to the corner, and there'll be less veering as it gets to the very corner. So the final included angle at the very edge may be something like 49 degrees instead of 60 in the previous diagram. And the resulting flat area here should be less than 1 millimeter. When it's less than 1 millimeter, it means that very little veering occurred as the fracture reached the corner, and therefore we have a sharper knife. Let me show you some more aspects of the glass knife making process. When we buy our glass strips, they have scores along each edge from when the glass strip was formed in a big machine. We call this the manufacturer's side because this edge was produced in the big machine by the manufacturer, the company that made these strips for us. Now it happens that we don't want our final break to occur on this edge, usually. Even though it's a nice square edge and it's straight and so forth, it's apt to be a little dirty even if we cleaned it, and it may have suffered some marring. Most people prefer to make the final knife edge from two fresh edges, and let me show you what I mean by that. Remember, let's take a 50 by 25 millimeter strip. That's one of the next to the last strips. So here's our manufacturer's edge. And this is a fresh edge that we made. Remember, we started with the 400 millimeter long strip, and we made first 200 millimeter strips, 100, and now this is a 50 millimeter one. So here we've got fresh edges, and here is the manufacturer's. And likewise, we break it again, and we end up with two squares. So each square will have two manufacturer's sides and two edges that were just freshly made. Now normally when we do all this glass knife making, we're going to try to be very clean. We may wear gloves, we may wash the glass strips, so that these surfaces here should be perfectly clean if we don't touch them. Okay, so now I'll show you how we usually like to put the glass squares in our instrument for the final diagonal break. We like to put them in such a manner that one fresh side is here and another one here. And these are manufacturer's sides. And then we line things up with our micrometers such that the score goes like this, and the final break occurs here and here, such that our knife edges are formed with two freshly formed edges. So they should be perfectly clean. Now we'll go ahead and start to make some glass knives with our instrument. But before we do that, don't forget to put on your safety glasses, and you may also want to wear gloves. The gloves will protect the glass from getting grease from your fingers, but also it protects your fingers from small glass chips as well. You remember, with each instrument you receive a box of 30 pieces of glass strips. And it's packed in separate packages like this, carefully wrapped. And we'll take one of them out, and here it is. Let's go ahead and make our first break. We'll put the glass strip in this way. I usually do it with the score side down. That would be this side. The original manufacturer's score would be along here. Now I'm going to flip this stop down, and now I'm going to push over until we make contact with the stop. Now notice that we don't push against these stops here, because that would actually give us the wrong angle. We push the glass against this bar here. The bar should be aligned against the back, the glass should be aligned against the back bar and pressed just touching the stop over here. The next step is to lower the anvil using this lever here. Now we want to score it. The scoring wheel is underneath and is operated by this knob here. We want to select scoring length number 1. That's right here. See, the white line lines up with the number 1. This will be the correct length for making the scores where we make squares or any of the breaks we make of the strip. The position number 2 will be used later for the diagonal breaks. Okay, now we'll go ahead and make the score. You should be able to see the line of the score. The next step is to break the glass. Now we're going to raise this lever here. This is the breaking lever. And when we do, what that does is applies pressure to the anvil on the top. Underneath here you'll see two button looking things. These are the pressure points from below. So actually what we're doing is we're pushing against these two pressure points below, and that will cause the score to deepen and widen and become the fracture. We'll have a look at that in more detail later. But first let's go ahead and make this break. Now because the strips are long at this point, I like to just gently touch the glass with my fingers so that when it breaks it doesn't jump. Did you hear it break? Now notice that we've broken the glass in half. This was a balanced break. And the reason they like to do the balanced break is because the weight of the glass is the same on both sides. Earlier glass makers would just take 1-inch squares from one end of the glass strip, and then there would be the other end hanging freely. And they often would not give nice square breaks. But when you do it balanced, you're assured of getting square breaks. So this piece now will be 200 millimeters long. Now let's make two 100 millimeter strips. I'll push our score back in, Doesn't matter if it touches the glass now, because without any pressure on it, it doesn't do anything. I'll lower the anvil. Oh, again, don't forget, I'm pushing against this back bar here slightly, and then just touching the stop here. I'm lowering the anvil, making the score. I like to just touch the glass. You don't have to. There it broke. Now I'll set this one aside. Maybe back here is a good place. Move it down. Push the scoring wheel in. Put the next stop down. This will be for the 50 millimeter squares. Or sorry, rectangles. Now I'll score again. Touch the glass. Raise the braking arm. Notice how I put my hand. This gives me good control with the braking arm. Now we've got two 50 millimeter rectangles, and now it's time to make our 25 millimeter squares. There's two of them. I like to lift the stop out so I get a better grip of it. And generally people don't like to touch the freshly broken edges, because those are the edges that are going to be used to make the knife edge. So we'll put these here. Put our other rectangle in, slide it in, let it touch the 25 millimeter stop, put the scoring wheel in, lower the anvil, score, and slowly break the glass. So now we have 4 rectangles. It's important that these rectangles all be the same length. And the reason for that is, otherwise our adjustments for the diagonal would be different. Some people don't want to even touch the edges at all on anything, but for now, just let's line these up so we get some idea of how they look. These 3 are all just right. This one's also the right length, but it's a little bit funny because, you know, this was the end piece. So this particular edge on the end piece is not as good as the edges we made. We might still be able to get a knife out of it. Probably not 2. But the other 3 are perfect squares, and all the rest of the squares we make will be great until we get to the other end piece at the other end, which will be completely unusable because it will be the wrong length, as you'll see. Okay, but we have 4 squares we can start with, so now let's go ahead and start to make some knives. Let's look a little more carefully now on what we've just done. We started with a long strip, and we put it down with the manufacturer's score down. Now you can recognize the score by the little teeny microchips that are formed along the bottom. That's where the manufacturer made his score when he made the strips. And I like to put those down and put the glass in the same way all the time. Now, how do you tell the fresh sides from the manufacturer sides? Well, here it's easy. We just made this break here. This is ours, and this is the manufacturer's. But when we get the when we get the squares, you have to look a little more carefully. You can tell a manufacturer's score because it'll go right to the corner, whereas the scores that we make don't go all the way to the corner. Likewise, you'll see a small divot formed in the glass from the pressure point on the top, whereas that doesn't occur on the manufacturer's side. Okay, now before we make glass knives from our squares, let's clean away any small glass chips that may have formed. That's what this brush is for. It's a good idea to periodically clean away the glass chips. Now this is part of the reason why we want you to wear safety glasses. not just because the chips could jump into your eye, but you may get them on your fingers, and if you're wearing safety glasses, it's not likely that you would rub your eyes. And that's when you could transfer chips to your eyes. That would be very dangerous. We don't want that to happen. But also we don't want the chips to be here while we're making our knives, because that'll interfere with making good contact and getting the right pressures and everything. So now let's look at the mechanism here a little better. Here you can see the scoring wheel. Do you see that all right? It moves in this slot and it's operated by this shaft. All right, let's go ahead and try to make a glass knife from one of the squares. Now I'm going to put it in with a fresh side here and a fresh side here. Manufacturer side here and another manufacturer side there. So I'm putting it in this way with the scores down, and it fits right into notches in the back and another notch that's controlled by this knob here. To operate the front notch, you need to pull back slightly and then pull away the flipper. Now the notch, which is under spring control, will go forward, and you want the corner to go into the notch. That aligns it up perfectly in the knife maker. Next, we lower the anvil. The anvil is lowered by this knob here on the front. We rotate it counterclockwise to the down position, and the anvil goes down. You've probably noticed by now that this is the anvil. Now, to score now, we want to make a longer score. So we rotate this knob to the number 2 position, which will make a longer score. I'll pull out the scoring wheel, and I made a score. I can see the score from either side. Now we'll go ahead and make the break. Some people like it to break very slowly. They feel that that produces better knife edges because there's less force when the fracture finally arrives at the edge. But we don't want to spend too long. I'm just going to go until it breaks. Did you hear it? Now the next thing to do is pull back on the front notch so there's no longer pressure on the knives. Now we put the flipper down to secure the front notch. We lift up the anvil using our knob on the front. Now we want to carefully pull away the 2 pieces so that they don't hit each other and wreck the edge that we just made. Now at this point, I like to lie them down the way they were formed. This one was formed here, and this one was formed here. So this is the way they were in the instrument when they broke. Why do we want to do that? Well, it's important now to look at them and see where the edges are. Okay, now let's look at the 2 knives we just made. Here's where one was made in the front corner. Notice what we call the narrow shelf. This is the flat area right near the corner. See that shiny area there? It's about 1 millimeter, maybe a little less. And the actual knife edge then is formed on the opposing piece right there. It should be a good knife. So this side here was a freshly broken side that we put in. And right here was a manufacturer's side. So this little flat area, sometimes called the shelf or foot, is formed here right alongside the manufacturer's side. Should be, anyhow. Similarly, at the other end, here we've got another fresh edge. Here we've got another knife that was formed. And there will be a shelf on this side that we can't see. It's facing the wrong way. So we have 2 good knives that are formed. Now that we have both these knives sitting next to each other on their bases, we can see the little flat areas. Now remember that the knife edge that was formed against this flat area, for example, is actually up on the other knife. See it up there. And likewise, this knife edge was formed against this flat foot here, right there, which is nice and thin and straight. Okay, let's go ahead and make another pair of knives. So I'll take another glass square and I'm going to place it in. Again, with the fresh side here, the other fresh side here, manufacturer's side this way, and manufacturer's side up that way. And you just stick it back in the notch there. It's funny, it's so dark in there you can't really see where it goes. It's black, but it can only go one place, into the notch. Now the front one you can see a lot better, and the notch is smaller, so you do have to be sure that the corner of the glass goes into the notch. Now how did I do that again? Let me repeat that. First I lifted the flipper up, and then I let the notch go forward, and then I guided the corner in just to make sure it went into the notch. The next step is to lower the anvil with the knob in the front. Now you don't have to put a great deal of pressure, just make it firm. Now we make the score. We want to check to make sure we're in position 2. That will make the longest score that we need for making the diagonal breaks. Here we go, let's make the score. Now you can actually see the score pretty well from either side. From one side it may look dark and the other side clear, depending on how it picks up the light. Now let's apply some pressure. I'm turning the braking arm up. It's interesting, you can see that the score actually looks deeper and becomes more pronounced. And as I mentioned before, you can just stop at this point. If you wait long enough, the glass will break by itself, and this would be the so-called slow break. It's got a nice deep score now that's made like a bubble that extends several millimeters up. But it's kind of stopped here. We don't want to wait too long. I'll give it just a little more pressure and it broke. Now let's lower this arm. Pull back the forward notch. Secure it with the flipper. Lift the anvil. Again, pull out the two knives. Separate them from each other first carefully. And then, as before, I like to lay them in the same position they were in when they were formed. Looking at them again, I can see that there was a nice narrow shelf here, a nice knife edge that was formed against it. Again, this was the fresh side. And on the back here, I see the same thing. A small shelf here, and a nice knife formed against it. Again, we'll turn these around and put them with the shelves or feet down, making a matched pair. It's okay to sit them this way because we're seating them on an edge that we're not going to use. That's the foot or shelf that's at the bottom, and the knife edge that's at the top. I like to keep them as a pair so that we can tell which knife was formed against which shelf. We get some idea of how sharp the knife is that way. Remember that if the shelf is very narrow and nice and straight, that might be your best knife. Should be your best knife. Well, you may wonder, why do we have these micrometers on this instrument if we are getting such good knives? Why didn't we just leave this mechanism all screwed down and tightened down in the correct position? Well, what happens is different glass from different manufacturers will be different widths, maybe 25 millimeters, or they may be 25.4, corresponding to 1 inch in width. And also there are different thicknesses of glass, and different thicknesses of glass require slightly different orientations of the notches and the square when we make the diagonal break. So it is important to be able to adjust it. Some of you may remember from older instruments, they were very hard to adjust, and people often left the adjustments just taped down in position with stern warnings, do not change. Well, what usually happened then is that they were never really very good for anybody, and no one was allowed to change them. But with this instrument, it's very easy to make the adjustments with these micrometers, and furthermore, we can write down the numbers and come back to the exact same position later. So if you find that for your glass and for your particular needs, particular settings are good or ideal, you've got those numbers written down and you can come back to them. Well, let's see what this is all about. First of all, when you receive the instrument, these screws were tightened down, and the notches should have been in a good position to break the knives and make 2 knives like we just did. In fact, that's how this machine was left. It was ready to be shipped. Now let's see how we use the micrometers. Let's see when we need to change the settings and how we would change them. And then we'll go to looking at how to read the micrometers. Here we are back at the drawing board again, and I'm going to show you how and why we adjust the micrometers. First, let's put our glass square in the instrument. And remember, we located in these notches. Here's the notch on the back bar. And here's the little notch on the front. Remember, it's got a spring, and we pull it out with this knob, and it's secured in place by the flipper, which I won't try to draw. Now, let's imagine that our knives aren't coming out right. For example, supposing when we break the knives, it results or happens that we get a large foot here and a large foot here. Now remember, the reason that would be bad is because we would end up with knife edges that would be less sharp than possible. It doesn't matter that the angle here will still be 45 degrees or close to it. But remember, when this foot is large, it happens that when the fracture shoots towards the edge or the corners, remember that it veers off and may form a final angle at the very tip of something like 60 degrees instead of something closer to 45 like we would like. So what do we need to do? Well, we can't really move the score, but what we can do is move the corners of the glass. And that's done by these micrometers, because this mechanism and this mechanism can both move. They can move left and right. So in this case, both the shelves are too large. They're greater than 1 millimeter. So what do we want to do? Well, in this case, we want the score to come closer to the knife edge here and closer to the knife edge down here. So how do we do that? Well, we have to move this corner this way. And likewise, we need to move this corner this way to move the score closer to the corner. Let me draw that again, but this time in a close-up. Here's the top one, the first break was kind of coming off this way and made too big a shelf. Remember, we can't move this score, so what we have to do is shift the corner. So we shift the corner this way. That'll cause the score to be pointing more towards the corner the next time. Let me just superimpose another score here. And this time, hopefully the knife edge will break and give us a nice narrow shelf here. And the angle here will be much sharper. Where it might have been 60 degrees here, we might come close to 49 or something like that if we can make this shelf narrow enough. This is the shelf again, the flat area. And likewise, we're going to do the opposite on the other corner. We'll be moving that in the opposite direction to make that shelf narrower. Well, now let's go back to the instrument and see how we do that. For consistent adjustments of the micrometer, use this small black knob here, which limits the pressure applied. This knob here is actually a lock for the micrometer. I recommend you leave it in the counterclockwise position here, which is the unlocked position. This knob here you need to unlock or loosen before you make adjustments to the micrometer, and then you need to tighten it again after you've made the adjustments. These screws in the front don't normally need to be adjusted or tightened. Just leave them as they are. Let's go ahead and put another square in now. Remember, we put it in with a fresh side here and a fresh side here with the scores down, just to be consistent. Now I release the flipper and bring the front corner into the front notch. Now at this point, we've decided already, or we're imagining, that our shelf in both the front and the back was too wide. So how do we go about changing it? Well, first, we want to make note of where the micrometer is to begin with. So without changing anything, we want to rotate the micrometer until the piston is touching the steel ball. Likewise, the one in the front. Now these numbers that we get on the micrometer now should correspond to the original numbers that were set in the factory. 7.05 for the back and 6.44 for the front. Looks like the front one's changed a little bit. That's not unusual. After all, it's shipped some distance. So here's the beauty of the instrument. We can record the numbers and come back to the same positions. But now we want to change them. We know the shelf is too big in the back and in the front. Remember, if it's too big in the back, we needed to move the corner in this direction. That moves the score in the other direction. Remember, we can't move the score, we can only move the corners. Again, in the back we want to move the notch in this direction. And the way we do that then is to first make sure our micrometer is touching the steel ball. Release this knurled knob here. Now you can see that the bar moves, and you can experiment with it to see which way it moves. We know we want it to come this way, so the original value was 7.05, so we want it to come this way, which means it'll be a bigger number. Now, the shelf was 2 millimeters wide and we wanted 1 millimeter or less. That doesn't mean that we move it a whole millimeter here. The amount that we move it will be actually less than you think. You'll confirm that yourself the first time you try moving it. Start off just moving 10 or 20 units on this dial to see the effect. Now let's make the shelf in the front narrower. Remember, we said it was 2 millimeters and we wanted it to be 1 millimeter or less. In this case, again, since we can't move the score, we can only move the corner. we want to move the corner in this direction. That will make the shelf narrower. Again, to do that, first bring the micrometer up to the steel ball, make a note of the reading, release this knob here. Again, if you want, practice to see which way it goes, and then increase it by some amount to move the corner to the right. It pushed it in this direction. As I mentioned before, you might want to try moving it 5 or 10 units here to begin with. If it's very close to the value you want, movements as small as 2 or 3 can have an effect. Now let's take a look at the numbers on the micrometer to see how to read them. You'll see that there's millimeters here. In this case, we've got 0, 1, 2, 3, 4, and 5 is above the 5 millimeter line. Now this is 6. It's reading 6.44 right now. Each rotation of this barrel corresponds to half a millimeter. The half millimeter marks are down below. Let me change the reading here to read 5.5 so you get the idea. This is 5.50 right here. Okay, let's go over how we read the micrometer. Right now it's reading 5. The cylinder is right on the 5 millimeter line. Now I'm going to increase the number. This is 5.05, 5.1, 5.15, and so forth until we get to 5.49, and here we are at 5.5. Notice now that the edge of the cylinder is lining up with the bottom mark now, and that is the half millimeter mark. The bottom marks are half millimeter marks, and now we're at 5.5. So this would be 5.55. The box said to try a setting of 6.44 to begin with. So that'll be easy. We'll just keep going until we get to, so here we are at the 6. You see we're one mark above, beyond the 5, and we're right at 6.0, and here we go to 6.4, 1, 2, 3, 4. And that was the setting that was suggested on the box to use for the front micrometer. These numbers correspond to actual shifts in the notches and the position of the corners. But remember, from the standpoint of our adjusting the score and getting the score to break at just the right place on the squares, these numbers are really relative. Again, the numbers are more to serve as reference points, and you only change them a little bit to increase or decrease the shelf. Let's just talk about cleaning and maintenance of the RMC glass knife maker. It's quite easy, actually. The most important thing is that the customer sweep away glass chips so they don't fall down into the scoring mechanism. And they want to also clean these glass chips up with perhaps a wet paper towel or something so they don't accumulate or get on someone's skin. Next, we need to look at the scoring mechanism and see how to clean and adjust it. To do that, first be sure that these knobs are secured in their position. You might want to write down the micrometer settings so that we can come back to the exact same settings. We're backing the micrometers off now, away from the steel balls, so that we can remove the entire mechanism here. There are only 4 screws that hold it in place. You just need a hexagonal wrench. Now, to get this mechanism off, you need to raise the anvil and move the scoring wheel forward, and the whole plate lifts off like that. So then you might want to brush away any glass chips or clean this at this point. Now we have access to the entire scoring mechanism and can easily remove it and clean the mechanism that holds it. To clean the mechanism, use a cotton applicator stick moistened with acetone. Then you can clean away the grease and any small glass chips that fell into this mechanism down here. To change the scoring wheel, remove the scoring cartridge, and you can use a paper clip to push the axle through the hole, and then the wheel will come right out. Remember, there are two replacement scoring wheels and a replacement axle supplied in a plastic bag inside the operator's manual. You then clean the cylinder here of the cartridge and put some grease on. You may use a chassis lubricating grease for an automobile as the grease. That's quite easy to get hold of. And then it goes back into position. If the score produced on the glass is either too deep or too light, we can adjust the scoring wheel pressure. We do that by removing the cartridge. And now I want to explain how it works. At the bottom of the cartridge, there is a wheel. This wheel follows the shaft underneath. This shaft has two positions. They correspond to the 1 and 2 on the front of the glass knife maker. That determines how long the wheel is riding on the shaft and is pushing upwards, making the score. Now, if we want to increase the depth of the score, the way you do that is you rotate this wheel. It's a little hard to see, but it has two notches in it, one on each side. The way you want to rotate that is using a small screwdriver pushing on the notch. Generally, to increase the score depth, rotate this ring with these two notches 1/8 of a turn counterclockwise. Likewise, if the score is too deep, try rotating clockwise on the ring 1/8 of a turn.
Okay.
If the scoring depth is insufficient, it may be caused by a worn scoring wheel. To change the scoring wheel, use a paper clip to push the axle through the hole, and then the scoring wheel comes right out. Be sure to do this over a clean sheet of paper so that you don't lose any parts. If the score is too light, there may be two causes for that. One may be that the scoring wheel is not pushing up hard enough against the glass. The other reason may be that the scoring wheel is worn. In that case, it's necessary to change the scoring wheel. You may first want to examine it under a stereo microscope to see if there are chips on the edge of the scoring wheel. If you want to change the pressure of the scoring wheel on the glass, the way to do that is to remove the scoring wheel cartridge, and then underneath you see a wheel, and you also see a ring with two notches on it. Use a screwdriver to push on the notches. To increase the depth of the score, or the pressure of the scoring wheel, rotate this ring 1/8 of a turn counterclockwise. To decrease the pressure on the scoring wheel, rotate the ring 1/8 of a turn clockwise. Do that by pushing on these notches. Now, after we're done cleaning the mechanism and we've applied fresh grease to the sliding mechanism and to the outside of the cartridge, put the cartridge back in, let it seat. Now let's take this black plate and work it back into position, just like that. That's pretty easy. Now try moving the scoring wheel from front to back. It should move easily. Now we'll begin to tighten the 4 screws. While you're tightening these screws, keep trying the scoring mechanism to make sure that the plate is seating properly and doesn't bind the scoring mechanism. Seems to be just right, so I can go ahead and tighten these screws now. Because the tolerances on the scoring mechanism and the groove that it slides in are quite tight, the plate should come back very close to the original position. So when we use the micrometers again, we can probably go back to the original settings and we should end up with knives with just the right size shelves as before. Maybe only a slight adjustment will be required. The wrench you need for these 4 screws is a 7/64 inch hexagonal wrench. Let's have a look at these stops. They have been factory set and they're secured to the top plate with these screws. First, make sure that they're secured tightly. After we make our breaks, we should measure the strip. This strip should be 200 millimeters long. The way we want to measure it is with a digital caliper, and we want to measure in the middle of the glass, like that. So the first break should result in a 200 millimeter strip. The second break should result in a 100 millimeter long strip, and 50 and 25. And they should be these lengths to within 0.1 millimeters. To make adjustments, it's quite easy. Use a 1/16 inch hexagonal wrench. First, loosen this screw here. This screw tightens the other screw, which is actually the stop, in position. To make adjustments, determine whether you want the strip to be longer or shorter. If you want the strip to be shorter, turn this screw. This is a 32 thread per inch screw. That means that one complete turn of this screw will, if I turn it clockwise, shorten the length of the strip by 0.8 millimeters. So if we want to change it by 0.1 millimeters, we would turn the wrench 1/8 of a turn. So it's possible with just a few adjustments to produce strips that are very close to the desired length. Once we have it adjusted to the correct length, tighten this screw to secure it so it won't move. If these stops are correctly adjusted, all the squares we produce should end up the same length to within very good tolerance, to within 0.1 millimeter. It's very important that the squares all be the same length, otherwise it's impossible to make the final adjustments of the micrometers to give consistent knives. Now let's measure the strip we've just produced. We want to measure from the middle of the strip, approximately where the stops make contact. And I see it's reading 100.12. That's quite close, but we might try to make it a little closer to 100. So the strip's slightly too long. So we want to shorten it. How do we do that? First, we loosen this screw here using a 1/8 inch hexagonal wrench. Then we want to turn this screw here clockwise so that it sticks out this way and therefore will cause the next strip to be a little shorter. One complete turn of the screw is 0.8 millimeters, so we need to rotate the screw 1/8 of a turn to shorten the next strip by approximately 0.1 millimeters. There'll always be some variation in the strip length, so once you get it adjusted to within less than 1/10 of a millimeter, let's say 0.05 millimeters of the desired amount, don't try to get it any closer. That's plenty good enough, and in any case there'll always be some variation.